Fake news is a piece of information that is being generated to gather some interest and manipulate people in a false sense. Recently, there have been many incidences in which fake news has reversed over the social media, like the Russian hacking incidents or some politician making some comments in the most popular 2006 US elections. According to New York Times, 64% of adults in US have been confused by fake news, and it is a socially significant area because fake news are able to create many riots and conflicts in the society. The fake news detection is still an open question. It hasn't been solved by anyone till the 100% accuracy. It's a real world problem in real time. That is why I'm motivated to do fake news detection as my project. These are some research papers that have gone through for my projects. The dataset I have used is the first dataset I used was a mixed dataset which was labeled as fake news and real news. There were around 18,000 news and a labeled dataset. Second dataset I used was also labeled dataset, but all the news in that dataset was fake. And the third dataset I used was a news or the dataset for all the real news. It has all the labeled news as real. All these datasets were obtained from Kaggle.com. First I tried, like Kim said in his paper in 2014, that CNN can be used as text classification by the use of glove vector and word-to-vec techniques, and they can give a very good result on text classification. The use of word vector in CNN allows the CNN to use their art of parameter sharing and reducing the calculation. But neither the CNN nor the traditional neural networks were able to guess the influence of the word in the beginning of a sentence to the word on the last of this in the last of the sentence. This problem can be removed by the use of long short-term memory network, or we can call them LSTM networks. These networks have memory gates like ignore, remove, update gates, forget gates, so that the words have influences on each other. This is the CNN model that I have been using. I have first imported all the libraries. This function clears all those data that we don't want to include in our CNN model. This is the sample of a fake news on which we have trained our model. I have first imported the dataset and then tokenized it into the vector form. Then I have converted the data into padded sequence to pass it into our model, and then converted the label into category form. I have used sklearn's train test split method to split the dataset into 80-10-10 ratio in test, train, and validation set. I'm not training the embedding layer. I have used a pre-trained embedding layer using glove vector of 100 dimension. This is the model that I have used, and the summary of a model is as shown on the screen. This is the overview of LSTM and convolution combination network. All the things are same as the CNN model. The only difference in this model is that after using a CNN layer, I have used a LSTM layer so that the accuracy of the model is increased and it is able to use the benefit of LSTM so that the word in the background can influence the word in the foreground. This is the overview of a very deep convolution neural network model. Uh, Here also all the helper functions are same. The difference in the model is as shown on the screen. I have made a very deep convolutional neural network model so that it can extract a great amount of features and give a nice prediction.
I will be discussing the machine learning model part for our project fake news detection. To begin with, let's start with naive-bayes classifier. It uses probabilistic approach and they are based on Bayes theorem. There are mainly three types of naive-Bayes models, that is Gaussian naive-Bayes model, multinomial naive-Bayes model, and Bernoulli naive-Bayes model. We use multinomial naive-Bayes model for our project to detect fake news, and we use a combination of real and fake news as a data set. Naive-Bayes is generally used to solve the real-world situation, and advantage of naive-Bayes classifier is that it only requires a less bulk of training data in order for classification purpose. Here comes random forest. It is a combination of decision tree. They use random forest regressor to classify the dataset. Then here comes decision tree. Decision tree is a tree-like model of decisions and decision makings. They are used for classification and regression purpose. They are commonly used for data mining. Decision tree regressor is used to classify the dataset. Then here comes k nearest neighbor. They depend upon the value of k, and their values are arranged in a feature space. They are actually done by approximation, and they store the entire data set. Then we can go to the coding part. Firstly, to begin with, we will be importing our data set, which is a combination of real and fake news, into the Jupyter notebook, and we will be doing the pre-processing pad and padding sequence pad in order for obtaining the actual correct alignment of the data set. Then we will be using the feature extraction part, that is TF, IDF vectorizer or count vectorizer. In order for the first model, name-based model, we will be doing this, and we will get an accuracy of the model about 90% accuracy is obtained, and the confusion matrix obtained for the model is this. And as we go to the decision tree model, here also we will be importing the dataset, doing the padding and sequencing part, and we will be getting the using decision tree regressor to classify the model, and we will be calculating the accuracy and the confusion metrics, and accuracy obtained for this model is about 73%, and confusion metrics for the model is this. And for the random forest, we will be using random forest regressor to classify the model. After calculating the accuracy and the confusion metrics, we will be getting an accuracy of the model of about 71%, and the confusion metrics obtained for the model is this. And next one is k nearest neighbor. For the k nearest neighbor classifier, we will be using k neighbors classifier to classify the dataset. After calculating the accuracy and the confusion matrix, accuracy obtained for the model is 53%, and the confusion matrix obtained for the model is this. So out of comparing the four classifiers, here we can come to a conclusion that multinomial naive-Bayes classifier will be giving more accuracy, that is 90% accuracy.
The result for the shallow CNN networks and very deep CNN networks and combination of CNN and LSTM networks are shown in the figure on the screen. And by the results, we can infer that the CNN and LSTM combination network perform the best. From this project, I concluded that the combination of CNN and LSTM network are best for text classification and are very easy to train also. CNN-based architecture are can be trained very quickly, but the performance is not consistent among the different type of dataset. LSTM perform different type of datasets for text analysis with very efficiency, but they are computationally very expensive. So we concluded that the CNN based network and LSTM based network can work very good in a combination. Thank you.